Welcome to Pindar Poetry. We hope you learned something new.
You begin by locking down compute and data. You need GPUs or TPUs and a clear budget, so provision nodes now. Clean and deduplicate your corpus, remove forbidden content, and split into train, validation, and test sets. Next, choose a tokenizer and a base architecture appropriate for your goals, BPE or byte level, and a target size like 7 billion parameters. This affects memory, batch size, and training time. Once done, prepare a small pilot dataset for a quick smoke test. You now build a robust training pipeline, stream or shard data to avoid I/O bottlenecks and keep reproducible seeds. Configure the training loop with Atom W, a cosine or linear learning rate schedule, mixed precision for speed, and gradient accumulation to simulate larger batches. Make sure to instrument checkpointing and model parallelism, tensor and pipeline, so your run survives preemption. Also integrate validation metrics and logging, so you can spot divergence early. If losses stall, adjust batch size or learning rate immediately. You finish by fine-tuning on task-specific data using a low learning rate and keeping regular evaluation checkpoints. Verify calibration and safety filters. For deployment, convert the model with quantization or pruning to meet latency and memory targets, and test batched inference under load. Monitor logs, performance, and output drift in production. Have an automated rollback plan. If you see hallucinations or training divergence, revert to the last good checkpoint, reduce the learning rate by 1/2, and rerun with cleaner data.
Thanks for watching. Consider subscribing if we helped you.